In two of the earlier videos, we've seen that when you try to differentiate sine of x, you will get cos of x. And when you try to differentiate cos of x, you will get minus sine of x. Now, what happens when you're given y equals a constant sine of x here? How would you find dy by dx in this case? Well, let's take a step back and try and understand something simpler. So let's try and understand in the case of y equals 3 x squared here. So when we try to differentiate this, we first have to sketch our graph here, and then so we would sketch our graph y equals 3 x squared, set up 2 points A and B, and then take the limit of take the limit as h tends to 0. So the true gradient dy by dx is given by this thing here. Now what I'm trying to illustrate here is that if you look at the case of the 3 here, the 3 is a number that doesn't change. So when you try and put it into here, when you look at this here, 3 is in common here, 3 is in common here. You're trying to take the limit as h tends to 0. This 3 here is not in any way connected to the h. The h is the thing that's moving about. You're trying to make h smaller and smaller and smaller. You see, this 3 here is a number that doesn't change. Here is a number that doesn't change. Because it's in common with this thing here and this thing here, you can actually factor out the 3. So factor out the 3, take the 3 out here, so it becomes this, and then you've got what's left. So because what I'm trying to say is factor out the 3. Well, let's go back one step. First we started out with this here. Keep an eye on the 3 here. The 3 is here. When you put it into this thing here, the 3 is here and here. You can actually factor out the 3. That will give you this times a bubble here. Now we then use one of the laws on limits. Well, one of the laws on limits is that because it's a constant, it's a number that doesn't change. You can actually take it out of the limit here. So just concentrate on finding out the limit of this thing here, and then whatever the limit of this thing is, then right at the end we can just times it by 3. So my point is that one of the laws on limits allows you to take this 3 out, because it's a 3 that doesn't change. It's a constant. So take the 3 out here. So in effect you will have this. You will have a number 3 times this thing here. Well, this thing here is really your true definition of the derivative of x squared. Because if I were to ask you what's the derivative of, how would you differentiate this, you would set up this thing here. You would set up this thing here, h squared minus blah 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 here, divided by h, and then take the limit as h tends to 0. That's this thing here. So this thing here is well, so for you to try and differentiate this here, 3x squared here, you can just take the 3 out and just concentrate on differentiating the x squared. So my point is that when you have y equals 3x squared, this 3 here you can actually take it out and just concentrate on differentiating this. So when you differentiate this, it gives you 2x, and then right at the end you can times it by, well, you can times the 2 together. So here dy, sorry, this is wrong. The way it's written is wrong. You start with dy by you start with y equals this, so dy by dx equals this, and then dy by dx equals this. Yeah. So when you try to differentiate this here, yeah, you can just concentrate on differentiating the x squared. Well, the same. Oh yeah. That's really us using this theorem here, which I've already shown you. When here you've got u here is a function of x. So u here is a function of x. Okay. So c here is a constant. So when you try to differentiate this thing here, because c is a constant, you can actually take the c out and just concentrate on trying to differentiate the u. Well, this is a theorem which I've already shown you. Okay. So here, going back to this thing here, first, if you want to differentiate this, if you wanted to, you can quickly sketch a graph of y equals 3 sine of x. That will give you this thing here. Okay, and then set up 2 points A and B, and then blah blah. Dy by dx, the true gradient that exists between A and B, is when you start to take the limit as h tends to 0. That would take you to this stage here, and look what happens to the 3. So originally we had y equals 3 sine of x. When you try and differentiate it, dy by dx equals this whole thing here. Keep an eye on the 3 here. The 3 here. See what happens to the 3 here. Okay. Now, even when you use the trigonometric identity to simplify this bit here, the 3 remains in place. So this thing here, when you use a trigonometric identity here, this block here is this block here. But notice the 3 is still there. The 3 is still here. And this 3 here is still here. So you can actually factor out the 3. Hang on. Let me move this across. So hang on. So look what happens to the 3. The 3 is still there. So originally, we had y equals 3 sine of x. So dy by dx gives you this here. And look at the 3, it's still there, even when you use a trigonometric identity here. So that then becomes this thing here. This 3 here is still here. This 3 here is still here. What I'm trying to say is that you can factor out the 3. Okay, so this thing here, 3's in common here, 3's in common here. Factor out the 3. Okay, so it becomes this. And then what's left here is really your derivative of sine of x. So yeah, this block here, I'm changing it back to this thing here. Earlier we started here, and then we used a trigonometric identity to take us from here to here. But now we are here. I'm just changing it back to what we had earlier. So well, my point is that this 3 here, you can take it out here, so it becomes this here, and then this here is our derivative for sine of x. Okay, so my point is that when you try to differentiate y equals 3 sine of x here, because 3 is a constant, you can just concentrate on finding out the derivative of sine of x. So when given y equals 3 sine of x here, pretty much ignore this 3. Concentrate on differentiating sine of x, which is cos of x. So dy by dx is really 3 times cos of x. So after all that, this thing here, when you try to differentiate this here, it gives you this. Okay?